For decades, we have organized human brain activity into neat, separate boxes. We treat sensation, memory, emotion, and cognition as isolated functions operating in distinct regions of the brain. This view produces a model of discrete processing blocks. It assumes neural data must be finalized within one functional region before transmission to the next. But a strictly modular model cannot account for system-wide phenomena. If thoughts are neatly isolated, it is difficult to explain why an unresolved memory suddenly intrudes on a current task, or how waking logic can merge so seamlessly into the associative flow of a dream. Instead of fixed compartments, researchers are increasingly looking at the brain as a continuously interacting dynamic system. In this view, boundaries are not hardware, they are temporary patterns in a larger flow. This brings us to the Brain Kinematics Model, or BKM, and continuity theory. This framework reinterprets brain activity not as a sequence of events, but as temporary organizations emerging from ongoing neural dynamics. To understand consciousness here, we must set aside the idea of a mental object and focus entirely on continuous, overlapping physical distributions. The first principle of the Brain Kinematics Model is that the brain never starts from absolute silence. No neural activity begins from zero, and every activity emerges from pre-existing flows. Brain activity is modeled as a continuous field of electrochemical and mechanical strain. The brain resembles an ocean of overlapping waves. A thought is not a particle, it is a temporary balance configuration, stabilizing into a specific shape before dissolving back into the background dynamics. These activities exist across nested temporal layers. A sensory flash lasts milliseconds, a sentence lasts seconds, and a complex scientific idea or an identity may span years. Under BKM, the traditional categories of psychology are reinterpreted as specific physical scales. They are different ways of measuring and arranging this underlying strain. Sensation is the most localized level of this interaction. It is the physical transduction of environmental energy, like light or pressure, into electrochemical signals. Within BKM, this localized strain input is a physical perturbation disrupting neural balance at entry. At this stage, the ripple has no inherent meaning, carrying only intensity and timing. Significance emerges only as this strain spreads and integrates with neighboring activities. This spatial and temporal integration is what we call perception. The brain organizes the raw ripples into stable, recognizable patterns. To create a stable object, the system matches this incoming wave against stored memory templates. A raw spike of auditory strain is recognized as the specific pattern of a human voice.
Perception, then, is the act of stabilizing environmental perturbations into a recognized continuity. As the perceptual wave continues to propagate, it intersects with deeper physiological and memory networks. A feeling emerges when an organized strain pattern becomes connected to emotional memory and body state predictions. The wave drops into deeper topological basins, gaining motivational significance. This process recruits the limb, shifting heart rate, muscle tension, and neurochemical balance. Zooming out to the macro-level system, we reach cognition, a large-scale longitudinal strain coordination.
It spans the cortices, linking diverse systems. This massive coordination allows symbolic integration. Scattered currents synchronize into a unified vortex capable of complex reasoning. The hierarchy is built on scale. Local ripples become perceptual waves. Those waves acquire emotional mass, and that mass coordinates into unified cognitive vortices. What happens when a cognitive vortex fails to find resolution and dissipate? Working memory is often described as a passive buffer, a temporary storage space for data. In the kinematics model, working memory is an unresolved active strain organization. It is a pocket of topological tension that continues to circulate because it has not yet reached a state of balance. Because these pending activities remain active, they constantly seek closure and bias how the brain perceives future inputs until the balance is restored. This physical persistence explains the Zeigarnik effect and the intrusive nature of unfinished thoughts. They are the inevitable outcome of unresolved neural strain seeking equilibrium. This model also explains the gap between waking logic and the fluid nature of dreams. Waking cognition and dreaming operate on the exact same underlying neural mechanics. The difference is a matter of boundary conditions. Waking cognition relies on sensory anchoring. Constant external inputs force neural waves into predictable channels, generating the experience of linear time. When sleep removes this barrage, the boundary conditions change. Without sensory anchors, the continuum is dominated entirely by internally generated memory activations and emotional currents. Subjective time becomes elastic and compressed. Logic becomes associative, merging concepts through emotional weight rather than chronological causality. A dream is not a separate category of experience. It is the waking system executing while unanchored from physical reality. This flow-based model reveals a fundamental flaw in how we study the mind: our reliance on subjective reporting. A verbal or written report is never a direct reproduction of an original neural activity. The original experience is a multidimensional, simultaneous event. A report is a secondary reconstruction that must compress that complexity into linear, symbolic language. This is a portrait of Elizabeth Loftus, whose research demonstrated that memory retrieval is an active rebuild rather than a high-fidelity replay. Recalling an event can actually distort or overwrite the original neural data. Dream reports are even more unstable. They rely on weakly indexed, unanchored fragments, making them vulnerable to rapid forgetting and reconstruction by the waking mind. Every report is a new continuum, generated from the residual traces of the one that came before. By integrating these dynamics, we can redefine the ultimate target of this science: consciousness. Systems in nature often strive for metastability, a state where they are stable enough to persist, yet flexible enough to transition to a new configuration. High-quality cognition requires a balance. Too much integration leads to rigid fixation. Too much dissociation leads to uncontrolled fragmentation. Consciousness is a continuously reorganizing, metastable continuum of interacting strain organizations. The mind is neither static nor discrete. It is a permanent cycle of emergence,